All right, there is a lot to unpack on this one. So, if you don't want to take the time to learn this one, you can go ahead and skip this question until you do the coordinate geometry section. So, I'm very quickly going to go ahead and explain it as if you have already done the coordinate geometry section and know how to do this. And then I'm going to go in depth in explaining it for those who need a little bit of extra assistance on understanding the aspects of this. So, first thing that we're going to do is not put it in our calculator. Anytime you're using the graphing function of your graphing calculator on the ACT math section, you are almost certainly getting tricked. And so if you want to save it for your third round, sure, you can go ahead and plug them in. But there is a very fast way to do the problem, and they're going to make it as complicated as possible to enter into your calculator. So I'm going to show you the fast way to do it without your calculator. So all that we're doing here, we can use our endpoints knowledge to find if this is positive or negative, which it is positive, and we can determine the exponent by just adding up the exponents of the different factors, which is going to be 4. And so because we have our endpoints memorized, our graph memorized, which we'll do here in a second if you don't have it memorized, we know that this is going to go up, up. It's going to start from up and it's going to end going up. So we can eliminate any answers that don't do that. So we can eliminate answer D, we can eliminate answer B, we can eliminate answer C. Those three are all gone based on that. And then based on our zeros, we can know that each of these zeros is going to be where it crosses or touches the x-axis. You just set each of the factors to 0 to find those zeros where it crosses or touches the x-axis. So we know we have a 0 at x equals 3. We know we have a 0 at x equals 2. And we know we have a 0 at x equals -1. And so this allows us to eliminate answer E because it doesn't touch the x-axis at all those spots. And so we have answer A. And we don't even need to use the behavior of the exponents for each of the different factors to be able to solve this. They've made it very easy. They just want to see if you have your endpoints graph memorized and know how to use it and know the basics of your zeros. So I'll go over those things now for those of you that don't know the basics of your endpoints chart and your zeros. But if you get this, you can go ahead and go on to the next question. All right, so first dealing with our endpoints graph. So this simple chart allows you to look at the leading coefficient of a polynomial and determine what the endpoints do. Do they go up, up, down, 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 up, down? And all you need to look at of the leading coefficient, which is the coefficient with the largest exponent, is it positive or negative? And is the exponent even or odd? And so I've written out a few practice problems here. I don't know if these polynomials are actually real, so don't worry about that. The purpose of this is just to help you practice the endpoints graph. And I want you to start off with number 1. So just based off of the leading coefficient, that first term in the polynomial, look at if it's positive or negative, and then even, and if the exponent is even or odd. Okay, so if the coefficient is positive or negative, and the exponent is even or odd, and go to that spot on our endpoints graph here and determine if this is going to start from up and go down, start from up and end up, etc., etc. All right, so you can pause the video if you haven't finished. We go to our negative and we look at the exponent, which is 4, which is even, And so we can know for number one, this is going to start from down and it's going to end going down. So it's going to look like this with a bunch of squiggles in between, but it's going to start from down and it's going to end going down. All right. Number two, try this one on your own. See if you can determine what the endpoints do. All right. So this one is positive and it is even. So it's going to start from up and it's going to end going up. All right. So it's going to be like this. It's going to have, start from up, do a bunch of squiggles, and then end going up. Simple enough. Number 8, it is positive and the exponent is odd. So it is going to start from down and end going up. So it's going to, start from down, then it's going to have a bunch of squiggles, and then it's going to end going up. Simple enough. Number 4, it is positive and the exponent is odd. So this one is going to also start from down, squiggle, 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 and going up. All right, we could make it negative, and then it would start from up, squiggle, 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 and going down. All right, simple enough. And therefore, you can take this information or take the information in the factored form to be able to determine what the endpoints are going to do. So I'm going to explain how to determine if it is positive or negative and figuring out the exponent just off of the factored form. So number 5, you can just look at it and see it's positive because the leading term out front of the parentheses is going to be positive. There's nothing there. It is just going to be positive. And you can see for number 6, it's going to be negative. And so now we just need to figure out the exponent. And so if there is no value on the factor, then that still has a 1. So the x out front has a 1, and the factor at the end, x minus 2, has a 1, even though it doesn't have anything there. And so now we just add up all of the exponents of these factors. So we have 1 plus 4 plus 3 plus 1. And so that gives us 4, 5, 6, 7, 8, 9. So this is positive with an exponent of 9. And so for this one, we know that it is going to start from down and end going up. We could also figure out the zeros, which we'll talk about here in a second. But let's just look at number 6. We know that this one is negative. We're going to add the exponents. Remember that x out front still has a 1 on it. So we're going to count that. So we have 1 plus 5 plus 4 plus 2, 5, 6, 7, 8, 9, 10, 11, 12. So it's a negative with a 12. So this is going to start from down and it's going to end going down. All right. And now we can go back and find the zeros since this is in the factored form. And all that you do for a 0 is set the factor equal to 0 and solve for x. So if you just have that x out front, we're just going to set it as x equals 0. And we know that at 0, we're going to have our line either touch or cross the x-axis. And then for x minus 7, we're going to set it equal to 0, solve for x, which is just x equals 7. So we know it at 7, it's either going to touch or cross the x-axis. Same for x plus 5. We're going to set it equal to 0, solve for x, which is x equals negative 5. So we know at negative 5, it's either going to cross or touch the x-axis. And then our final factor here is going to be x equals 2 is where it's going to cross or touch the x-axis. So go ahead and do the same for number 6. See if you can do it on your own. You can pause the video. I'm going to go through and do it. So we know that x equals 0 is going to cross or touch. X equals negative 3, it's going to cross or touch. X equals negative 8, it's going to cross or touch. and x equals 3. It's going to cross or touch. So to go one step further, which you don't need to be able to solve the question that we just did, you can look at the exponent and determine what it's actually going to do at that 0. And you can determine if it's going to cross or touch at that 0. If the exponent is even for that factor, it's going to cross. If the exponent is odd, it's going to bounce. So we can go through each of these. And so for the x by itself on number 7 here, we know that the exponent is 1, and therefore at 0, which is what this is, we set it equal to 0, we know that it's going to cross at that 0. So we don't yet know if it's going up or down to get to that spot, but whatever direction it's coming, it's going to cross at x equals 0. And then at x equals 7, since the exponent is even, it's going to bounce. So it's going to hit 7, and if it's coming from up, hit 7, it's going to go back down. If it's coming from down and hit 7, it's going to go back up. But either way, it's going to bounce. X equals -5 has an odd exponent, 3. So we know at -5, it's going to cross there, cross to the other side. And then at x equals 2, remember, if it doesn't have anything there, the exponent is 1, it's also going to cross here. And we could, if we wanted to figure out the endpoints and then map this out, we could now just map out the entire thing without a graphing calculator very quickly and easily. All right, so let's do the same for number 8. Pause the video, go through, see if you can figure out if it crosses or bounces at each of these different spots. So at x equals 0, the exponent is 1, it's going to cross. At x equals -3, it's odd, so it is going to cross. At x equals -8, it is even, so it's going to bounce. And at x equals 3, it is even, so it's going to bounce. And if you want to go further on this, like I said, our coordinate geometry lesson, and specifically the zeros section and the endpoints section, are going to be pertaining directly to this question. Hopefully this helped.